Hello, I'm Yang Shi from Intelligent Big Data Visualization Lab, Tongji University. I'll be presenting our work, supporting expressive and faithful pictorial visualization design with visual style transfer. This work is in collaboration with Pei Liu, Siji Chen, Mengdi Sun, and Professor Nan Cao. Pictorial visualization is a visual representation of data. It uses icon-based language to visualize otherwise abstract data points or data facts. It has been increasingly incorporated into narrative visualization such as data videos and infographics to support data-driven storytelling for the general public. However, creating pictorial visualizations is a challenging task, even for experienced information designers. To facilitate pictorial visualization design, various data-driven design support tools have been proposed. However, these methods are restricted to certain data types such as proportional or temporal facts. Moreover, they constrain the visualization type being used in examples to be identical with that in results. Such an approach may reduce the expressiveness and flexibility of pictorial visualization design. To bridge such a gap, we leveraged a concept derived from the field of artificial intelligence, style transfer, to separate and recombine visual style and data content, enabling a more extensible approach to crafting pictorial visualizations. Built on the concept of style transfer, we developed a design support tool called vStylist. As a user uploads a source pictorial visualization collected from online sources, vStylist can automatically extract its visual style and transfer the style to an intended pictorial visualization. Let's see a demo. Initially, a user uploads an example to the design panel. vStylist automatically segments its visual elements. Then she uploads an obesity dataset to the data panel and clicks the generation button to check the result on the canvas. She can adjust the icon and color of the visualization. Also, vStylist shows alternative designs in the suggestion panel. Our system was developed to address a set of design requirements we had derived from the interviews with domain experts. In the following, I'll explain each design requirement in detail. First, we identified a set of design patterns of pictorial visualization to guide automatic generation. These design patterns can be described as a function of 6 visualization types and 7 data binding types, and were identified by analyzing a dataset of more than 1,000 pictorial visualizations we collected. The dataset can be accessed through the following link. The user interface of vStylist shows only the 6 visualization tabs in the data panel and hides data binding types from users. As a user selects a specific visualization type and field channel mapping, our system can automatically suggest data binding types. Second, vStylist decomposed a source pictorial visualization into visual elements that characterize its style. To perform element extraction, we applied one of the state-of-the-art object detection methods proposed by Liu et al. Their method can distinguish between 4 categories of data elements of infographics, including text, icon, indexed, and arrow. After successfully detaching the identified elements from the source, we extracted their features, including color, font, and icon. Third, to generate an intended pictorial visualization, vStylist performs a 3-step procedure. First, drafting a pictorial visualization based on the dataset, selected visualization type and suggested data binding type. Second, automatically retrieving icons that are semantically associated with the selected data attributes. Third, transferring the extracted visual style to the intended pictorial visualization. vStylist can also suggest alternative designs of pictorial visualizations based on 3 criteria, including similarity, aesthetics, and inspiration to help design ideation. Specifically, similarity measures the results by comparing them with the source pictorial visualization, and the most similar one amongst the results is ranked the highest. Aesthetics evaluates the results from the perspectives of color and layout, while inspiration provides design alternatives by suggesting different visualization and data binding types. In our evaluation, we estimated the usability and usefulness of vStylist through a survey of example pictorial visualizations, a controlled user study, and a series of expert interviews. In the survey, the participants were presented with groups of pictorial visualizations generated by vStylist and retrieved and adapt respectively. In each group, they were asked to compare the resulting pictorial visualizations with the source and rate the quality of the results using a 5-point Likert scale. The results showed that vStylist performs significantly better than RTA in terms of consistency, expressiveness, flexibility, individuality, and inspiration. In the user study, the participants were asked to use vStylist to create pictorial visualizations based on the given sources and fill out a questionnaire. In the expert interview, the experts were asked to create pictorial visualizations with vStylist first, and then use the results to create infographics with graphics editors they prefer. That ends my presentation. Thank you for your attention.